Assalamualaikum.
So, Assalamualaikum and good afternoon. Can you hear me?
Yes, Dr.
Bismillahirrahmanirrahim. So we continue our lecture on the root locus, chapter 1, by referring to the slide number 14. Okay. So the question arises from the previous lecture: can we draw root locus for a higher order system? Okay. So the answer is yes. Okay. But before that, we have to see the properties of the root locus, because these properties is really help you in order to sketch or freehand draw a root locus for a higher order system. Okay, so let's consider a closed loop system with a feedback HS. Okay, so this is the closed loop system. Okay, TS, right? And if you see down under here is the denominator of the TS of the closed loop. So this denominator is the equation. We call it as a characteristic equations. Okay, so this characteristic equation is equal to 0. So when the equation equal to 0, okay, the S polynomials, if you factorize using your calculator or using your MATLAB software, you will get the roots, and these roots is known as closed loop poles. Okay, so a pole exists when the characteristic polynomial or denominator becomes 0. Therefore, we can conclude that this is known as a magnitude criteria. Okay, KGS, HS is equal to 1, or if we take the modulus on the left and on the right, so this minus 1 will become 1, and then is equal to the angle criteria, which is 1 angle 2K plus 1, 180 degrees, where K is equal to 0, 1, and 2. Okay, so let's see our, I share using a whiteboard so that everybody can see. Can you see my iPad? iPad? Yeah.
Yes, Dr.
Yes.
So slide 15. So alternatively, we can write it as here. This is we call as magnitude criteria. So please remember that modulus KGS HS is equal to 1, and angle criteria, which is angle KGS HS is equal to 2K plus 1, 180 degrees. Okay, thus a pole of the closed loop system cause the angle of the KGSHS to be an odd multiple of 180 degrees. Okay, so it can be 1, 3, 5, and so on. So the magnitude of KGSHS must be unity. Okay, like this, unity. So when we simplify this equation, okay, so K is equal to 1 over GSHS magnitude. Okay, so from there we can calculate the value of gain by including the value of S. Okay, if you has the S value, you insert the S value inside here, then you get the value of the gain. So from the previous example, okay, this example, we want to check, okay, is it a closed loop pole exists at minus 9.47 and minus 0.53 when the gain K is equal to 0.5. Okay, so what we do is we plot it, okay, using a MATLAB. S is equal to TF bracket S, and then we key in the transfer function by assuming K equal to 1. So 1 over S multiply S plus 10, okay, and then R locus G, then grid. Okay, so you get the plot, and then you substitute this one minus 9.47. Okay, then you will get the K value is equal to 5. Then it is fulfill the angle criteria of KGSHS equal to -1 or modulus KGSHS is equal to 1. So all the closed loop must satisfy the requirement of the magnitude and angle criteria. Okay. So we have a system here. The open loop transfer function is Ks plus 3 S plus 4 over S plus 1 S plus 2. So K is the gain. Okay, guys, K is the gain. And then the open loop poles is -1 and -2. And open loop zeros is -3 and -4. Guys, right? So this is what we call as the unity feedback. Okay, unity feedback, FB, right? So this example asking if we have a point -2 plus J3, is it a point, a closed loop pole? Is it a closed loop pole or not? Okay, so we have a test point here. Okay, a test point. So we have to test either -2 plus J3 is on the root locus or not on the root locus. Okay, so to be a closed loop pole, as we know that this point must fulfill the angle criteria and the magnitude criteria. Okay, so we draw this point, which is a -2 plus J3, okay, on the S-plane. So this is the imaginary, and this is the real axis, right? And the open loop poles is -4, -3, sorry, open loop zeros, and open loop poles is -2 and -1 respectively. And then we have a θ1, which correspond to open loop zeros -4. We have a θ2, which is correspond to open loop zeros -3. And then we have a θ3. So θ3 is the correspondent open loop poles, and θ4, which is correspond to open loop poles -1. And then we have L1, L2, L3 and L4, which is the length. L stands for the length. Okay. Theta is angle, right? So angle criteria said angle of zeros, total angle of zeros, okay, minus total angle of poles is equal to odd multiple of 180 degrees. So this is the angle criteria. So theta 1, theta 2, theta 3, and theta 4 from the S-plane here. Right? So how are we going to get theta 1? How we get theta 1? Muhammad Hadif, can you give an idea how you get theta 1? Hadif? Muhammad Hadif, tak datang. Spektra.
Ya, Doktor.
Ha. Nama awak siapa?
Tak, Doktor, saya lupa nak tukar nama tadi. Saya
Nama awak siapa?
cepat. Saya Imam Irfan.
Irfan, okay. Irfan, bagilah idea how to get theta 1.
Doktor boleh, Doktor scroll atas balik. Saya pun tadi
Yang inilah, senang.
yang
Tolong. Jadi senang sikit. Yang jimat masa 1 jam. Okay. Theta 1 equal to?
ni kalau buat cara map biasa macam tu boleh, Doktor.
Ya, bacalah. Awak tengah tolong ni.
Tu lah.
Berapa?
Calculator saya pun tak ada.
Astaghfirullahalazim. Budak-budak zaman sekarang ni. 56.56.31 degrees. Okay.
Contoh dapat ada.
Alright. Okay. Okay. It's okay. Then theta 2. Theta 2. Ahmad Najwan. Theta 2. Ahmad Najwan tak datang Tak datang. Absent. Asnawi.
Sekejap.
Theta 2.
71.57.
21.57.
Bagi Asnawi. Asnawi cepat.
71.56.
71.56. Senang je. Okay, sebab Asnawi read from the notes. Nah, dia smart. Dian, Zulhelmi, theta 3. Zulhelmi, theta 3. Tak datang.
6.
Theta 3 bukan 6 Theta 3 is 90 degrees. Okay. Yeah, it's 90 degrees. Kan? Then theta 4. Theta 4.
108.43.
Theta 4, we have to calculate this one first. Dia punya opposite ya. Okay. 1 and 3. Konyawen.
Yes, Doctor.
Theta 4.
Theta 4, 108.43.
How you get that?
I find the opposite angle using tangent. Then I get the opposite angle is 71.57. Grade 18 minus 71.57, I get 108.43.
Inilah, like this, huh?
Yeah.
Okay, understand, So when we make a total, so it is minus 70.55. So meaning that it's not equal to 180 degrees. So automatically, if the point is not satisfied angle criteria, so automatically -2 plus J3 is not on the root locus, and therefore it's not a closed loop poles. Then we change the point. We change the point to -2 plus minus J square root over 2, which is 0.707. Okay, 0.707 like this. Okay, okay, which is a positive J 0.707. Then we calculate theta 1, theta 2, theta 3, and theta 4 again. Okay. So in this case, if you calculate the theta 1, Chung Hui Ki, theta 1.
Hello.
Chung.
Tangent
Mhm.
square root 2 over 2
Tangent, inverse tangent,
square root 2 over 2.
0.707 divided by 2 mah? Berapa?
Yeah. 19.46.
19? 19.
19.47.
19 eh? This one? Okay. Right. Thank you. Amir Zafran. Theta 2, please. Tak datang. Amir Zafran.
One minute.
Berapa?
Uh, 35.26.
35.26. Okay. And then theta 3 is 90 degrees. And theta 4. Theta 4 berapa? Ismail. Theta 4.
180 inverse tangent 0.707 over 1. 144.74.
100.
44.74.
Okay. So theta 1 plus theta 2 minus theta 3 plus theta 4. How much? Okay, you can calculate, add this one, you add this one, and then, sorry. And then you add this one, and you add this one. So it will become 180 degrees. Okay, thus it is a point on the root locus. Okay, and then when it confirmed as a point on the root locus, so you have to calculate again using the magnitude criteria, which is L3, L4, L1, L2. L3, L4 is the length of the correspondent poles. L1, L2 is the length of the correspond zeros. Okay. right? So how you calculate L1? Siapa mana? How you calculate L1? Rafana, tak datang?
Ada.
Tak nyawa. Saya Prof. Berapa? Baca. Ikra.
Sorry, 2 to the power of 2 plus 0.707 to the power of 2.
So, baca lah dia punya value tu ada kat notes.
2.121.
Okay. Atika, L2. Atika, L2.
Ada 1.22.
Okay. 1.22. L3. Okay. Paling senang sekali. L3.
0.707.
Cepat kau. L4.
1.22.
Same lah. Okay. So that's why this one can be cancelled. So it becomes 0.33. Okay. Understand? Understand, guys? So that is by calculations. But if you want to do it by computing to verify and to validate either the given test point or closed loop poles is on the rule locus or not, you can use my MATLAB coding. Okay. For example, this one -2 plus J3. Okay, we assign the SS and then we insert inside the G. Then we find the theta. Okay, theta 180 divided by pi multiplied by angle. So we use a function absolute G. Okay, so absolute G for the angle criteria. Okay, so and then for the magnitude, and then K is equal to 1 divided by M. So you get this value for G and for theta, which is not equal 180 degrees. But for this point, -2 plus J, 0.707, inside the G, find the theta, find the magnitude, and then find the gain. Okay. Okay. So you get -2 plus J, 0.707, -3, theta 180 degrees. This one is subsoi. Okay. Lebih kurang 180 darjah, 180 degrees. The magnitude is 3. Okay, and then the gain is 1/m, which is 0.33. Okay. So this is what we call a product. When you calculate the magnitude, excuse me, it's a product, right?
Satu.
Apa dia? Siapa tu? Lokman. Lokman.
Sorry doktor, ada orang tanya soalan tadi kak saya.
Okay. So product of numerator divided by denominator, right? So is the length, zero length and pole length for the magnitude, and the angle is total of zero angles minus total of pole angles. Okay, and this is the formula. So some examples for you to try. Okay, given a unity feedback that has a forward transfer function k s plus 2, which is s square plus 4s plus 13. So if you find the roots, it will give you a complex number, which is s is equal to -2 plus minus j3. So you have a real part and you have the imaginary part. And then test either -3 plus j0 is on the root locus or not. Okay, the answer is yes, and the gain k is 10. So how we calculate that? So it's very simple. First, you draw the S-plane. So this is the S-plane. Okay, j omega, and real axis. And then this is the test point, -3 plus J0. In fact, it is a -3 lah, a real value. And then you calculate the theta 1, theta 2, and theta 3. Okay. So theta 1 is here, 180 degrees. Okay. 180 degrees. This 0 correspond to the test point. And then for theta 2 is 108.5. Okay. 108.5. And then theta 3 is 251.5. Okay. So from here, we calculate it fulfill the 180 degrees. The magnitude is 0.1. So K divided by 0.1 is equal to 10. Okay, the gain of the system. This is 1/10. So please remember this formula. Okay, please remember this formula in your heart. Okay, it's not given. So how to calculate the gain by calculations? So 3.16 multiply 3.16 is divided by 1 is equal to 10. Okay, is equal to 10. Tanyalah, how do you get L2 dan L3 tu? How you get L2 and L3? Diana Camelia, how you get L3? Because L2 and L3 is the same. Liana Camelia, tak datang? Ivan, how you get L3?
Surt 1 square plus 3 square.
Surt
1 square plus 3 square.
Are you sure?
Yeah. Yes.
L3.
Yes.
1 square.
Then plus 3 square. We'll get 3.16.
Betul ya? Betul tak? Please check. Terima.
Yeah, 3 square.
3 square. 3 square plus 3 square.
AR.
3 square plus 3 square. Correct.
1 square.
1 square, Doctor.
1 square.
How you get 1 square?
-2 to -3.
Oh,
The distance.
correct. Correct. Okay. So the answer is 3.16. Okay. Okay, yang ini 1 ni is 3 minus 2. Okay, so you get 1. So so when we plot the ruler curves, okay, so it have one open loop poles at -2. Okay, and this one is -2 plus J3. This one is -2 minus J3. So the ruler curves, the theory of the ruler curves is the ruler curves will start from 0. Start from poles and ended at zeros or infinity. So start from here. Okay. Start from here. Then they met at this. Break in or break away. You are Rajan. Break in or break away.
Break in.
The value?
5.
Minus 5. Ibarujan.
-5.
Minus 5. And then one will go towards the 0 over here, and the other one is go to the infinity, right? Example 2, this one is a more higher order system, s plus 2, s squared plus 2s plus 17 over s plus 10 multiplied by s squared plus 9. So check whether minus 9 is on the root locus or not. Okay. Right, so we plotted the locations. We have 3 open loop zeros. Okay, minus 2, minus 1 plus minus j. Then we have 3 open loop poles, which is minus 10, minus j3 and plus j3. Okay, and the test point is over here. The test point is minus 9. Okay, so if you look using the plot, okay, you can see that we have 1, 2, 3 root locus path. This one start from poles and ended at zeros. This one also start from poles, ended at zeros. First RL, second RL, and the last one is this one, starts from minus 10 and ended at zeros, minus 2. So obviously minus 9 is on the root locus, right? So that's why we calculate the gain, which is the length of the zeros divided by the length of the poles. Okay, so we get 0.161. So how you get 0.161? The easiest way is using a MATLAB programming. Okay, the other way is by calculations. By calculate the L1, L2, L3, and 4. Okay, so pole length divided by zero length. Sorry, tadi I cakap 0 divided by pole kan sebenarnya is length of pole. This is poles length, and this one is the zeros length. Okay, so you get 0.161. Then we verified using a programming, so you get the more or less a similar value. Okay, so this is the tutorial that we discussed just now. Okay, so it's answered already. Okay, in the slides. So in order to construct a root locus, we have several rules that we must follow. Okay, the following rules allow us to sketch the root locus. Okay, after sketching, the root locus can be refined. Okay, so before sketching, first we must mark the open loop poles and open loop zeros on the S-plane. Then after that, we start using the rule 1, which is number of branches or number of root locus is equal to number of open loop poles. So if we have 3 open loop poles, meaning that we have 3 root locus. If we have 4 open loop poles, so meaning that we have 4 root locus. Then root locus have a symmetrical properties, okay, which is symmetrical on the real axis. Okay, so this is your S-plane, this is your imaginary, and this is the real axis. And usually it's symmetrical on the real axis, okay, not on the imaginary axis. And then on the real axis, rule number 3, okay, for k is greater than 0, the root locus exists to the left, okay, of an odd number of real axis, finite open loop poles, and zeros. Okay, so that one we describe in the next slide. For example, for rule 1 and rule number 2. Okay, so you have a S-plane here, imaginary axis, real axis. Then you plot the open loop poles, -10, -0. So the open loop poles is 0 and -10, meaning that we have 2. So that's why the RL path is equal to 2. Okay, the first one is this one, go up, and the second one is this one, go down, like the previous example. So the two branches are shown here, originate from -10 and 0 origin, okay, due to the open loop poles, and it is symmetrical of the real axis, meaning that if we flip, okay, this S-plane, if we flip, okay, on the real axis, so it will touch each other, okay, will face each other. Rule number 3 is here, okay, on the real axis for k greater than 0, the rule of the RL exists to the left of -1 and -3, like this. Okay, so you have two poles, open loop poles, -2 and -1. Okay, so it met each other, okay, and break away. Okay, one will go here, the other one will go here. Okay, sorry about my handwriting, I'm not good in drawing. Okay, and then one split to the zeros, ended at the zeros, and the other one ended at the remaining zeros. Okay, you can see that here is a breakaway point, and here is the break-in point. Okay, BIP, BAP, BIP. Okay, so this is the proper root locus drawing by computer. Okay, so starts from root locus start from poles. Okay, and then breakaway. Okay, and then ended at zeros on the left. Okay, with two breakaway point. So two break point. One is BAP, breakaway point, and this one is the break-in point. Okay. Any question you want to ask? Any question? So far okay? Guys, so far okay?
Yes, doctor.
Natra, faham? Natra Hasan,
Saya doktor.
faham?
Faham?
Alhamdulillah. Rule number 4 is starting and ending point. So the rule locus begins at the finite and infinite poles of GSHS at k equal to 0 and ended at the finite and infinite zeros as k towards infinity. Okay. For example, if you have this open loop transfer function, okay, so usually rule locus we plot based on the open loop transfer function. Okay, open loop transfer function, then we plot the RL. Not closed loop, open loop. So have a 3 finite poles, okay, which is -1, 0, -2. Okay. Nampak? S plus 1, S plus 2 equal to 0. So you get -1, 0, and -2. Okay. So when we multiply, so we have a S cubic, 3S square plus 2S plus 0. So we have a characteristic equation, which is S cubic, 3S square plus 2S equal to 0. So this one we call it as a characteristic equations. So for rule number 4 is shown here. Okay, starts from poles, ended at the zeros. Okay. Poles, and then begins with the finite -1 and -2, ended at the finite zeros, -3 and -4. And then for rule number 4 here, okay, so you can, when we plot it using a MATLAB, okay, so you still remember how to plot it? S bracket G 1 over S cubic plus 3 multiply S square plus 2 multiply by S. Okay, so this one meaning power of, okay, cap symbol or hat symbol in programming. And then R locus G, and then put the grid. So you get this one. So -2, -1, and origin. So starts from poles, breakaway here, goes to -infinity, positive infinity, and this one no friend. Okay, so look to the left, and it goes to the left at the minus infinity. So the root locus approach, straight line as asymptote as the locus approach infinity. So asymptotes is the guide, is a guidance for the root locus to move from the poles to the zeros. Okay, so first we have to calculate the number of asymptote first, which is the numbers of finite poles minus the numbers of finite zeros. And then we find the sigma A, which is the real axis intercept. So we find the total values, okay, total value, okay, total value of poles minus the total value of finite zeros, okay, and then we divide by the number of poles minus the number of zeros. So you must understand the value and the numbers is not the same. Value is a value lah. Like this case, okay, the value is -1 -2, okay, plus -4 -3. Okay, so the numbers is, number of poles is 2 minus the number of zeros is 2. So 2 minus 2 equal to 0. So the value and the numbers is two different things. And then calculate the angles, theta A, which is 2k plus 1 multiplied by pi, which is 180 degrees, divide by the numbers of poles minus the numbers of zeros. Okay, so when we calculate that, we have the asymptote line. We have a 3 asymptote line. Okay, this one, and this one. Okay, where the sigma A is over there. Okay, the real axis intercept. Okay, real axis intercept, which is sigma A. So examples, sketch the rule locus for the system using rule number 1 and 5. Okay, so we sketch. Okay, this one is open loop zeros equal to -3, open loop poles 0, -1, -2, -4. Okay, so automatically we have 4 root locus. Okay, we have a 4 root locus. Okay, so when you calculate here, this one is root locus number 1, root locus number 2, root locus number 3, and root locus number 4. Okay, there are more open loop poles than open loop zeros. Thus, there must be a zeros at the infinity. Okay, and the angle of the line that intersect is minus 4 divided by 3. Okay, which is here. Okay, the angles of the line that intersect, the real axis intersect, sigma A. So if we look at the formula here, sigma A, okay, total of finite poles minus total of finite zeros. Can you calculate that? So we calculate zeros, minus 1, minus 2, minus 4. Okay, minus 4 using the formula minus total of zeros, total minus 3. Okay, divide by number of poles 1, 2, 3, 4 minus number of zeros 1. How much do you get? Minus 7 plus 3 divided by 3 minus 4 divided by 3. That's why you get this minus 4 divided by 3. Minus 4 divided by 3, real numbers berapa? Muhammad bin Said? Minus 1 point.
Yes, doctor.
Muhammad bin Said?
Yes, doctor.
Minus 4 divided by 3. 1.333. Am I right?
Yes, doctor.
Okay. So this is the real plot from these examples. Okay. So we have 4 open loop poles. Okay. So that's why we have 4 root locus, 4 branch. Okay. This is number 1. This is number 2. This is number 3. And this is number 4. Example 4. Sketch the root locus for your unity feedback shown here. Okay, verify your root locus using a MATLAB. So this is the open loop transfer function. So open loop zeros. What is open loop zeros? Faris, Haikal. Open loop zeros.
-2.
Open loop zeros.
Oh, 0.
No, 0 is the value. Not exist.
Not exist.
Not exist and 0 is 2 different things. Kemudian Faris, open loop poles.
-2, -4, -6.
Right. Thank you. Okay, so we find the real axis intercept. This one. Real axis intercept. So the value of poles is -2, -4, -6, minus the value of zeros. Jelek, tak ada. Okay. Actually ni tak payah because memang tak ada pun. It's not exist kan. La mawjud. In Arab we call it la mawjud. Sami, is it correct?
Yes, doctor.
Not exist is la mawjud. 3 minus 0, the numbers of poles is 3 and the number of 0 is 0. So this one will become -12 divided by 3. So it is -4. So that's why the sigma A is over here. Okay. And theta A is the asymptote angle. Theta A1, 180 divided by 3. A2, 180 degrees. And theta A3 is 5/3, 180 degrees. Okay. Rule number 6 is the real axis breakaway and break-in point, as I discussed previously in the previous examples. So the root locus break away from the real axis at the point of maximum gain. Now, please remember this, maximum gain. Okay. Break away point. Okay. Break away point, maximum gain. Break in point, minimum gain. Okay. The gain is minimum. So the break point occurs between a point of maximum gain on the real axis between open loop poles. Okay, so the characteristic of breakaway points is between open loop poles and for break-in points between two zeros. So that is the difference between break-in point and breakaway point. I repeat again, breakaway point where the maximum gain, K max, which is over here, and this one is gain minimum, K minimum, between two zeros. Can you remember? Jason? Jason Lau?
Yes, sir.
Yeah, the difference between BIP and BAP. Okay. And in order to find the breakaway point and the break-in point, by computer is very easy. You using your mouse, okay, so you can get the value like 2 days ago lecture. But to prove it, okay, to prove it from your observation by calculations, you have to know how to calculate it. Okay, so to find the break-in point and the breakaway point, we use the maximize and minimize of the gain K through differentiations, meaning that we differentiate the open loop transfer functions and equal it to zeros, and then solve for S. Okay. Example here. Okay. So you have the KGSHS. So you have to differentiate. Okay. Differentiate. Okay. KGH, which is S square minus 815. Over S square 3S plus 2. So D per DS KGH. Nur Hazika, how you calculate the breakaway point? How do you differentiate this? Nur Hazika? Datang. Tak datang. Absent. Daniel? Daniel?
Daniel MTS ke Daniel JKP tu tak?
Daniel. Yang satu lagi Daniel. Daniel.
Saya Daniel.
Ya betul.
Differentiate.
Tak ada idea.
Oh Allah ya Tuhanku. Dah tak lupa ke?
Saya try adik tu.
Try.
2S tolak 8 bahagi 2S tambah 3.
B square.
Oh.
S plus 2. 2S minus 8 minus plus 15. 2S plus 3. Divide by S square plus 3S plus 2 square So all equal to 0. Okay. So you simplify. Simplify, so you will get okay. So you will get that. So can you find the roots? Nur Hazika? Datang. Tak datang Chua? What is the roots for this? Chua? Tak datang.
Yes, doctor.
Jangan tidur, Chua.
No.
11s square minus 26s minus 61.
Wait a minute. 3.82 and negative 1.45.
I pakai my CPU, so I get 3.82. Sama. So, if based on the what do you call that? Common sense. Okay, which one is positive? Which one is negative? This one, isn't it? 3.82 here, breakaway point, and break-in point is minus 1.45, right? After you differentiate, then you get the simplified, and this one you get the quadratic equation. Quadratic equations. So this is the way we calculate the breakaway and the break-in point. Or if you don't like the differentiations, you just take the what do you call that? Open loop zeros, open loop poles. 1 over sigma minus 3 plus 1 over sigma minus 5 equal to 1 over sigma plus 1 plus 1 over sigma plus 2. And then you simplify, you get the same quadratic equations and the same break-in point and breakaway point. And this one can be programming. We can program it and get the maximum gain breakaway and minimum gain break-in point, okay, by using a computer programming. Okay, so it proved that on this side is the this one is break-in point, okay, and this side is the breakaway point. Okay, terbalik ni pergi sini, ni pergi sini, terbalik. Okay, rule number 7, wakaf. Atikah,
Yes, doctor.
wakaf. 50. Slide number 50. Okay.
Okay, doctor.
Tika, can you be my secretary? Boleh?
Boleh, doctor.
Upon you. Okay, any question, guys? Any question, guys? Allah Akbar. Ada soalan nak tanya?
No, Doctor.
No, Doctor. Alhamdulillah. Alhamdulillah. So next week is Ramadan. Okay. Sunday holiday. 1st of Ramadan. Bulan puasa. Puasa tak?
Puasa, Doktor.
Daniel, puasa?
Puasa.
Arab brothers? Arab brothers? Arab brothers?
Yes, doctor.
Ramadan Kareem.
Ramadan Kareem to you,
Ramadan
doctor.
Kareem, Doctor.
Ramadan Kareem.
Ramadan Kareem
Arab
to you all,
brothers.
Ramadan Kareem, doctor.
Senegal brothers? Senegal
Yes,
brothers?
doctor. Yes,
Ramadan
doctor.
Kareem.
Ramadan Kareem to you, doctor.
Allahu Akram. Okay, so happy Ramadan. Selamat menyambut bulan Ramadan. Class still on, insyaAllah, on Monday, 11 11 AM. Any question? Any question? No
It's okay,
question.
Doctor.
Question. Thank you, Doctor.
Lunchtime, okay. So I will share the YouTube link later, inshallah. So Wakaf, stop at slide number 50. Thank you very much. Bye-bye.
Right. Jazakumullah khair. Thank you, Doctor.
Thank you, Doctor.
Thank you,
Thank you.
Doctor.
Thank you,
Thank you,
Doctor.
Doctor.
You got the